Right, okay, I think we'll make a start. It's 3 minutes past 3. So good afternoon, everyone. Thank you for coming along this afternoon. My name's Oliver Caius. I'm a senior lecturer in digital business at Liverpool John Moores University. And it's my pleasure this afternoon to introduce our speaker, Dr. Christina Phillips, who also is a senior lecturer in business analytics at Liverpool John Moores University. Christina and I are not just colleagues. We don't just work in the same school. We actually work together on the same team. So I've gotten to know Christina very well in recent years, and she has quite a diverse background, having worked in quite a few different areas, but her expertise lie in mathematics, business analytics, and participative modeling. She plays quite an active role in the community. So she's the co-chair of the Analytics Network. And I believe she's is it your second term now, I think, Christina, serving as the board of directors for the OWA Society.
Yeah.
So without further ado, I shall hand over to Christina, who's going to talk to us today about some work she's doing, which is called the je ne sais quoi of algorithms that foster human-centric analytics design. So we'll have about 30 or 40 minutes talk from Christina, and then we'll have time at the end for any questions that people may have. So Christina, over to you.
Thank you very much, Oliver. So the slightly disingenuous start to this is the title, the je ne sais quoi of algorithms. It's great for getting people in the rooms. Probably make a great paper title, but actually there is no je ne sais quoi, which we will find out as we go through it. Basically, it's all about context, which is a very design-orientated way of looking at things. So what do we need algorithms to do to foster human-centric analytics? So to start off with, what's human-centric analytics? Let's actually sort of set the stage for this. So human-centric analytics is a design paradigm for creating analytics that augment human work in complex settings that require high human involvement. And this came about because I was working in a very complex organization that had biological ingredients, so they want to change a lot of humans having to manage the processes, and an awful lot of regulation. And after trying to implement multiple different types of analytical solutions to help them smooth their production and be better at production and scheduling, I realized that it was only ever working when we actually did it in a very human-centered way. Then turning to the research on human-centeredness, I found very quickly that actually there's an ISO for computer science and computer systems, which actually is all about human-centric design. And this isn't HCI, this isn't human computer interaction. This is about designing systems in a way which is human-centered. And there was an awful lot that was in that ISO that seemed to really resonate with what I was finding with human-centric analytics. But of course, analytics sits at a different level. It's not just about the systems that we're interacting with, and it's not just about the data or even the mathematics that we're using. It's about all of that as it comes together and how people understand it and how people use it. And as I say, it's a design paradigm because it's very much from the point of view of being contextualized. So you need iterations of development. You need to be working in the context of the human beings that are doing it. And you need to have an opportunity to be able to reflect on what's happened and what's happening. And also, to some extent, to actually be able to watch the designs that you're making as they go into use and how people are adapting and using them. And then be able to be responsive to that, which of course requires a fair amount of resource. It means that you've got to be pretty hands-on, but it also means that you need certain things to be in place in order to be able to use algorithms in that way. And that's what led me to being interested in this piece of work as my next big piece of work. It suggests that we need to bridge between the humans and the analytics, and that bridge actually needs focus. It needs study focus. It needs us to research it, to understand it better, and to understand better how we can do that. I used the Mangle of Practice to view humans, processes, and materials as being in a dance of agency. So you're actually seeing the material thing as the algorithm as actually having some agency, which means that you then watch as it's changed and adapted by people, and you kind of give that credence as much as you give the way that humans are changing credence, which allows you to see into the situation and redesign and design on it much better. Because you're looking at everything and how everything changes, including the mathematics that you might be using, because you might decide, well, actually that algorithm doesn't work there, but if we use this one, people will understand it better because it speaks to their context better. It posits that what we actually need to do is to set up a dialogue between humans, the algorithms, and the analytics that they're likely to use. And by affording that opportunity of dialogue before you even put anything into place, what you can end up doing is designing something which is far more fit for purpose than if you just get a needs analysis, run off, make something, bring it back in the room, and then everybody goes, oh, no, it's lovely, but it doesn't do what I need. Which, I'm sure every analyst has had that moment. And the other thing, I talked to the National, the Valuation Office, the Audit Valuation Office, Valuation Audit Office, that's it, last week in government. And it really resonated with them when I was saying that, a lot of people are really wedded to their spreadsheets. They've got everything on a spreadsheet and they've used it for years and they're like, no, this works for me. I'm wedded to I like my spreadsheet, and they don't really want to let it go. And in order to persuade them to let it go, you need to be able to have this dialogue where they can tell you what they love about their spreadsheet. They can show you their spreadsheet. They can get you working on it. And then you can show them what you can do with it to make it that much better and to help them to get directly to what they need faster. At which point, then they're much more open to working with you. So not only are you watching the design in use, helping to iterate that design, you're also giving people the opportunity to have some agency over what's going on, which in a lot of cases, especially in complex organizations, is really important. But how do we get algorithms to actually foster that? And that was the crux of this. So the human-centric analytics also suggests that contextualized mathematics becomes much easier to understand if the pattern matches the context. So I had for instance, where I was using forecasting algorithms, secondary forecasting algorithms, to explain to people what was going on with their forecast. And I actually used one algorithm, which is quite complex. It's called a mapper algorithm because it's a multiple aggregative prediction algorithm that aggregates over lots of different time periods. Now, normally people would find this really difficult to understand, and I wouldn't have dreamed of putting the mathematics past them. However, the actual output of the algorithm, these people really understood because they actually had to forecast at lots of different aggregations. So the fact that the algorithm was doing it at different aggregations and they had to do it at different aggregations meant that even the most complex algorithm was understood by the humans who were involved in it because it matched their context. Now, of course, that's not something that we can say, well, algorithms are going to foster that, but perhaps it's an argument for meaning that we actually need many ways to do something, many ways to do the same thing. It looks to give that direct agency to both the humans and the analytics. And this is why you need to bring the people and the analytics together, because that way you can have, the analytics can show what they can do and the humans can show what they can do with it and how much they understand it. And it offers an opportunity for learning and communication. We need to seek an agreeable level of granularity. And by granularity, I mean the cross-sectional temporal scale that we're choosing at, the choice of parameters that we put into the model. I'll use an example in a minute and open that up a little bit more. And then, as we all know, KISS, keep it simple, stupid. Simple models are often best, and we can iterate to complexity. And this is very much agile design kind of space. So soft OR and design can help us in understanding context and creating a space for dialogue. They're really good techniques to bring us into that space. What I would say is you need an awful lot of design work up front with this, and you need to go round that space quite a few times with some of the stakeholders who are going to be involved in it. Algorithms tend to need to be bespoke, or if they're not necessarily bespoke, they're pulled off the shelf and then they're made bespoke for the situation. So what I found was, it was when I listened to people, really listened to what they said, gathered evidence on what they were saying, then went away to the data, gathered data that was relevant to what they were telling me, and then tried to turn that into things that could speak to them, particularly in a visual way, that I actually started getting traction with analytics, and we started getting somewhere with stuff. And there was massive behavior change around it as well. The thing is, not all algorithms can have an adjustable granularity. Some you cannot adjust. So then perhaps you need multiple things that you're throwing at the situation to give people some choice. Sometimes it's very difficult to actually provide choice. Some have very defined parameters, but you've got a bounded choice. So for instance, you've got something like natural language processing. I did a project with NLP. Really wasn't sure that this design paradigm would work with it, because they'd already decided they were going to use NLP. And I would usually say, you don't decide up front what you're going to use. You go into the situation and then decide what you're going to use based on the situation, because it speaks to the people. However, in this case, natural language processing was what was required. The thing is, NLP does have a place that you can adjust. You can basically adjust the labels. So we used a lot of iterations of workshops where we would bring the labels into the room and say, what do you think of those? And then from the workshops would actually gather more labels that we could then look for in the data. And then from our findings, we took that back into the room with the same group of people and then said, what do you think of these findings? And then we were able to then iterate on that and then go back to the algorithms. So you can work it, but there needs to be something that can be adjusted. So obviously simulation is quite nice in this space. Tried and tested techniques are things like discrete event simulation, agent-based modeling, system dynamics, all simulation techniques that need to elicit needs and have to have some kind of expert input and preferably some expert validation to say that the model actually fits the domain. They're used in multiple modes, like you can use it for domain exploration, scenario planning, digital twinning. And there are some very nice techniques around already to do this in a way that actually facilitates human involvement in the development. So Party Sim was something that I used quite extensively, and it couples discrete event simulation and soft systems methodology. And it does this through a series of workshops, and the early workshops talk around the model design. Then you have a basic design is set up and a parameterization. So you work towards this granularity, setting the parameters, getting the timestamps right, knowing what you can model and what you can't model. And of course, during this process, people start to learn the limitations of modeling, but also start to think in a way which is almost turning their complex problem into something which is more defined, discrete, bounded, and actually helps them to think in that way. And I know that there's been numerous papers written by people like Kathy Kotiadis and Robinson about actually working towards a DES model, and then what comes out of the participation in the creating of the DES model actually turns out sometimes to be more powerful than the DES model itself. So I think what PartySim was trying to do was actually encapsulate all that good stuff and put it into some umbrella methodology which would help people to do this in practice. DES has also been used with business process modeling and notation. It's been used with ethnography, and it's been used extensively with lean management techniques. And all of these things have been written about in the OR journals. System dynamics, from its very beginning, when Forrester first created, was very much rooted in eliciting the needs of people who were involved in it and creating a learning journey which would bring people together and bring the problems together with the people, so that you actually got something that grew out of it that was usable and would get used. It's been used with problem structuring methods specifically, and it's been used quite a lot. Well, more recently, we've had developments on behavioral system dynamics and looking at the way people behave with regards to the models. Agent-based modeling has used things like serious games. They've used questionnaires, and they've used cognitive mapping. I think some people have even used Delphi with it. And that's been used to help actually elicit the needs for the agent-based model, or have the agent-based model embedded within those things. Multi-criteria decision analysis and methods, they also elicit needs. And it could be argued that it was developed specifically to work with people. There has been an awful lot of research by people like Val Belton, which is all around the needs elicitation process and how you do that really well. So MCDA, I think, has always been a human-centric analytics technique, and it has been developed in a human-centric way. It's just that it hasn't necessarily been acknowledged as that's what it's doing. But I would argue that the human side of eliciting these is just as important as the mathematical development in MCDA, MCDM. And I think my co-author, who's now going to be working with me on this paper, Nadia Papamikali from Manchester, she has worked extensively in MCDA and has written papers that argue this. So we go, well, isn't this decision science? Is this not just decision science and it's just a progression in decision science? I mean, Nadia herself has run the decision sciences SIG for the OR Society for many, many years. Well, it kind of is and it kind of isn't. It's more of a process. So it's not necessarily decision science. It's more of what process do we need to go through to create the best decision model at the end of it? How do we need to design this? And that's not necessarily about how people decide things. So decision science is important as a part of it, but it's not actually the end product. What the end product itself is actually the process of doing this. It's very much OR in practice. So you need things like iterations, reflection, codification, structuring. And this is in the realm of soft OR and problem structuring methods. So for quite a few years, I was actually co-chair of the problem structuring methods special interest group. And this is partly why, even though my work was initially, analytics, and I come from a mathematics background, I found I needed to use these techniques to actually make my work work. So ended up with a very keen interest in this area. There are some computer-based systems that try to structure and bound algorithms to make it easier for people to understand with them and to interact with them. So Isabella Lamy over, I can't remember what university she's at, I think she's in France, or no, Italy, for multi-criteria decision analysis. She actually set up a page where people could set the criteria. And this basically crowdsourced a way to set criteria, and that was with respect to architectural design. So it was a criteria for architectural design. Reusable DES, discrete event simulation models, Thomas Monk et al. Have done this. They basically set up a database of reusable discrete event simulation models with certain outlines as to how the model's working. So what it models, what parameters it uses, what timestamps it uses, all of that sort of stuff. And then basically the things that can be changed as part of it. So it makes it easier for people to be able to reuse the models without having a deep expertise of the area. There's reusable crowdsourced explanations for AI models. Anne Lirette gave us a really interesting talk at last year's Analytics Summit on this. Basically, what they've been doing is they use an ontology of explainable AI algorithms, and then they use that to provide explanations for how a particular AI is working when people want an explanation for what's going on. They also then take user feedback on that. So the user can feedback how useful they found it, how comprehensible they found it. And in doing that, they've been able to build up this model, and they can create it bespoke for different situations, basically. It was a really interesting piece of work. Labeling for LLMs can be a participative expert-led process. There's been some work at Bolton College doing this, and they picked up people who were retired teachers to actually do the labeling on an educational AI, so that it was actually doing it the way that teachers would do it, and it was doing it with expertise. So it's expert-led labeling, basically, which has immense amount of power rather than labeling it by whoever's guessing at it. AI is an important part of this. And AI is also something that we need to think very hard about how people are going to use it, and how it can be used to help people. So the explanations for AI model was actually using AI as well as explaining AI. Ethics and responsible use, of course, become a big part of the puzzle, especially when we're talking about something like AI, which has a lot of black box about it. And all of this, to some extent, is, I see it as being very cybernetic. You have a black box, and it's like, well, what are the inputs and outputs that we can tweak? What can we change? And then when we do change it, what's kind of going on? You don't need to have a deep understanding of it, but it does need to have some kind of contextual explanation that says why it's right for this situation, because otherwise people just won't trust it and they won't have any faith in it. Visualizations are an incredibly useful tool for interpretation, but they do need very careful design, and there are lots of different studies on how people will interpret different visualizations. And it can cause bias and it can cause anchoring. I went to talk this morning which was exactly about that. So explainable AI is a really important part of this. They're calling it XAI now. I personally think that explainable AI is actually slightly different to interpretable AI, but I know a lot of people would put them under the same banner. For me, explainable AI is when you can explain what the AI does or how it may have come to its conclusion, although you're not going to know deeply how it came to its conclusion. Again, we're in black box territory. Whereas interpretable AI would actually be it's becoming a white box. It's no longer a black box. You now actually can interpret how the AI came to the conclusions that it did. It was initially about data scientists, operational researchers, people like that, understanding the algorithms they were using. But now it's extending to human-centered design because now everybody's using AI and it's becoming ubiquitous in the workplace. So you've got researchers from human-computer interaction and user interface design are now taking an interest in explainable AI. It is translational, and I would say that all of human-centric analytics is translational. So we can learn from HCI and UX what's needed for explainable AI, but also vice versa. And with human-centric analytics, we can learn about how people utilize analytics, operational research, in context and the process of actually putting it into context. But we can also learn about what we need to do in order to make it usable for them. So there's this multiple learning thing going on, and we're learning about different aspects as we're doing it, which can make it quite confusing because there's lots of things that you need to evidence as part of this. But it just basically, for me, it means that it's a very big field, a very rich field for research. Transparency is really important with explainable AI. How it came to be, how it did what it did, why it did what it did, and what if we did this to it, what would it do then, especially for extremes testing and stuff like that. So counterfactuals are very useful and used a lot to say sort of like, well, okay, it did that there, but what if we did this? Yeah. Performance benchmarking is very useful. And very importantly, we need to make sure that the data provenance is really clear because, most of the time with an AI, if you want to know why it did what it did, it's like, well, what data did it use? And that's going to tell you why it did what it did. Interpretable AI, as I said, I see this as being a bit different. It's often put under the banner of XAI, but it's where the algorithm actually tries to be understood. So you either have to completely redesign the algorithm or you have to take outputs at different stages. Now, with most neural networks, that actually means a complete redesign of the neural network, or certainly a redesign of the perceptron, so that you can actually understand, the perceptron can actually give you something that is comprehensible, so you can understand how it used the data to come to the decision that it did. It won't always be understood, as of course that's down to individual perception. And each person in the room may have a slightly different perception of what's going on. Much of this work is in machine learning, and there has been some work to make neural networks more interpretable. And I'll cover that in a minute. So Paolo Lisboa at Liverpool John Moores, he's now left and he's gone into consultancy. However, one of his students, Sandra Mortego, she's doing a lot of work in this area now. I say Paolo Lisboa et al. Because there are a lot more people who are involved in this than just Paolo, but he's the name that I knew when I first put this together, and it was his papers. He basically completely redesigned the perceptron. I think this was working with Sandra, and it uses a generative additive model, a GAM, built from multi-layer perceptrons. And basically, it's completely redesigned the perceptron and the way that the perceptron works so that you can actually say, this is how it's using the data. Now, this is very powerful when it comes to people like, doctors working in medicine, and they want to be able to use AI to inform what they're doing, but they need to know why it came to the decision that it did. The problem at the moment is it only works for pairwise comparisons. However, it's often more accurate because of the way that it works. So it's actually, highly accurate. But again, it's down to the data. The thing is, it does give insight into how the model is actually using the data. So I think Sandra has just recently been given a very big grant to work on this, and thank goodness for that. I think this work is really important. This is where we need to go with AI, particularly for those situations. They also created support vector machines with radio-based kernels for domains where interpretability of classifiers was an issue. So you need to know why it's decided to classify it as this or that. Is it a banana or is it an orange? And you want to know why it put it into banana or orange. The components are visualizable. So basically you can visualize these components so that experts can see what's actually going on. Which means that the experts can then validate it and say whether it's reasonably close or very far away. So it means you can pick up those extremes that are going on. It's a nice interpretable model, and it's not restricted to the main effects inputs, but because you can see if there's outlier effects, you can actually see these. So that's really nice way of actually interpreting that. And like I said, there's a lot of work going on in this area at the moment. Someone else who's been working in this domain is Dolores Morales Romero, and she would be horrified if she saw me putting her name on the slide, because actually what she's been doing, she's an extraordinary optimizer in OR, and she's actually been having quite a few PhDs who've been working on this work. So it's a lot of her students who've actually been putting these papers out. She's done work to use counterfactuals to tune machine learning classifier outcome. And that allows a tunable granularity by the users. So users are actually able to tweak the way that the algorithm's working. So this gives that point of agency. It creates a decision tree that resembles the black box model, but is actually a bit easier to interpret. Now, this is still, the machine learning classifier is still doing a black box thing. But the fact that you're able to do something which allows people to tweak that helps them to get more insight into it than they would have otherwise. They've also used optimization to create a set of explanatory variables to make explanatory vector analysis a bit easier to interpret. So it introduces this idea of a goodness of fit criterion that quantifies the quality of interpretation. So it tells you how good that interpretation is, which is something we could all do with LLMs, I think, at times. It used a similarity approach to make clustering, they also used a similarity approach to make clustering more easily interpretable. So it maximizes the true positives and minimizes the true negatives. So you're more easily able to see into how the clustering algorithm has actually worked and what it's been doing, and whether you think, actually, you know what, that shouldn't be there, it shouldn't be working like that. So it, it allows the limitations to be seen. Some other techniques which are very useful when it comes to working with people because they can be explained. One from Milonas et al., which was they call LXDR, which is local explanation of dimensionality reduction. So one of the problems when you get huge data is you've got to use things like principal component analysis to try to reduce the dimensions of the amount of data that you've got and take out the dimensions that aren't really useful, or reduce those dimensions to a fewer that are it's like the factor analysis, so fewer dimensions that speak about what your data is doing rather than having all the dimensions there at once. The trouble is explaining how that's working to somebody who hasn't got any background in hard operational research is a very difficult thing to do. It's hard enough trying to explain it to students who've got great A-level results in maths when you're doing an analytics course, to be honest with you. So this extracts interpretations via linear models that map the original dimensions to each of the reduced dimensions. So now you can see on your reduced dimensions what original dimensions are actually on it. And you can see quite clearly how they're on it, basically, with a linear model. It trains the linear models around a neighborhood of a specific instance. And so it provides local interpretations. Now, this can speak to people's context because it actually sort of like, they can see the things that they've put into the model. They can see the variables that they understand. And it actually starts talking about how those have been interpreted and put into this reduced model. Another one that's quite useful, but is extremely difficult to explain, is topological data analysis, which doesn't rely on coordinate systems, and it's actually based on the shape of data. What it does provide is intuitive maps of colored data connections, and it's really good for high dimensional, very complex data sets. Here's an example of topological data analysis. And this is on lots and lots of animal data. So this is, I think this was things walking past a point. So it's actually saying, recognizing what they are, basically. Poppy and sunflower wouldn't be walking past it, but yeah, I think it's, it's actually looking at a domain and then mapping what it is on each one of these. And you can see that it's turned it into colors. And then these colors, people have then labeled as to what they are, what it's actually recognizing as these colors. Topological data analysis is very, very interesting, but it is a difficult area to access if you're not mathematically trained. And even some mathematicians I know would shy away from topological data analysis because it can be quite complex to understand, which I think is why it hasn't taken off as much as it could. I think it's also rather specific for the type of data that you would be working on. So if you've got extremely complex data with a lot of different variables in it, then that is a candidate for topological data analysis. But when you're working with smaller data, probably not. It's not really going to help, and it's going to confuse more than it's going to help. There are more. There's a lot more, and there's more to consider as well. So what about low code? Low code environments are really helpful if you can teach people the basics. So something like KNIME, for instance, it has what they call modules, and each module does something. And that module might be as simple as, transform this column to a row or this row to a column, or it might be as complex as now do a regression on these columns. So the nice thing is, if you can teach people the basics of how to use it, they can put the blocks together. The problem is sometimes they could put blocks on things that they don't really understand what's going on, get an output they think makes sense, but actually, if you looked at it from the point of view of somebody who's more an expert, you'd go, no, that doesn't actually do what you think it's doing. So it's the same danger as we get in a lot of these visualization environments. I mean, I've been teaching Power BI this week, and I see students doing stuff and they've actually got numbers that don't make sense. So I spend quite a bit of time trying to get them to try to make sense of the numbers on things to see whether that visualization is actually showing what they think it's showing. Accessible visualizations on that subject, things like Tableau, Power BI. I think Tableau is more accessible than Power BI is, but Power BI is on more machines. Accessible data manipulation, so things like KNIME, Alteryx, which does a similar thing, Tableau Prep. Now, all of these are very, very nice for data manipulation. They can be taught to undergraduates. They're very straightforward once you start knowing what goes on when you press the buttons, and it's really great for helping people to understand how to change and alter their data so that they can speak to people about the problems that they've got. So sometimes actually just being able to turn the data into a format that's more comprehensible is actually a really big part of the journey. Yeah, keeping it simple. So there's network analysis. I mean, tools like Gephi are free. They do lovely maps. Again, you get into a domain where it's like you really need to know what you're doing to be able to actually get really good visuals out of these things. But it's very useful for talking to people about network effects because you can show what's going on. So I used that for some Twitter analysis and actually took that back into the room with stakeholders that we were working with. And they all found it extremely interesting. We were basically showing where a lot of misinformation was coming from by using that analysis. There's adaptive resonance theory, which I won't go into in detail. We've had enough explanations, I think, or art. It's basically a tunable thing, and it kind of goes up and down the data tuning itself to come out with generally clustering, but it can be used in a few different ways. Paolo is very keen on this because it's something that you can use with people, because it's quite easy to explain how it's doing what it's doing. So if it's in the right circumstance, that's actually a really nice technique. Fuzzy numbers, fuzzy sets, difficult to explain, very easy to understand. And anybody who's done a lot of simulation, occasionally you must turn around to somebody and say, okay, so what does it go between and what's its maximum point? And before you know it, you've got a triangular number. So, you know, sometimes it's much easier to allow people to go, well, it's between here and here, than it is to just say, like, give me a point. Yeah. So fuzzy numbers and fuzzy sets, I think, model the way humans do things a lot better than points estimates. I'm sure I've missed many more. There are many more out there. And I guess as I'm working with Nadia over the rest of this year, we will start to tease out the dimensions of this. We've already started trying to do it. We're actually using multi-criteria to help us to do this. There are lots of, the dimensions of it is something that we're working towards. So to summarize, we've got explainable AI, which tries to generate transparency through structured query. We've got interpretability, looking at the use of data by algorithms. So we're trying to interpret algorithms by redesigning the algorithm completely so that we can actually see what's going on. So we're turning the black box into a white box. Making those black box out. There's also the way of doing it of making the black box outputs easier to tweak and easier to understand, which is the work that Dolores has been doing. There's crowdsourcing inputs, as in large linear models with feedback from experts and expert labeling. There's crowdsourcing explanations and choices with feedback to improve the explanations that people are getting and which choice of algorithm, which choice of explanation you're going to give them. And doing things like having data banks of, like, you know, if you want a model that does this, this is what you want to go for. Visualizing outputs and visualizing the use of inputs and how those inputs are being used. So, you know, that helps when you're doing something like participative modeling. You can actually go, well, okay, these are the inputs we're using and this is what they look like when we use them in this context. Low code, as I explained with KNIME, that's a low code environment, so we have to be careful around the limitations of that. How much do we need to train people before using low code environments? And data transparency. Data transparency, I keep going back to, from the point of view of ethics, it's really important as well. And for that, we need validation, governance, and we need to know the provenance of the data. And that's a really important aspect. And I think, final thoughts. Well, whether the software is proprietary or not is kind of important for this stuff. You know, quite often you can't get access to it if it's proprietary software. But then if it's free software, you also got problems on security, you've got problems with maintenance, and you've possibly got problems with whether you're going to get the backup you need when you need it. You need the right tool for the right job. And sometimes that's not attractive for academic specialists, and that can make it hard working academically in this domain. Because, you know, for instance, with the natural language processing project that I worked as part of the reason why we had to use NLP as our solution for the situation was because the researcher who'd gone for the funding was an NLP specialist. So it needed to be an NLP project. But once we got in the room with the patient groups and the people who were doing the messaging in these patient groups, which is what it was all about, there were other things that became as important, if not more important, things like the network algorithms. So it can be difficult for an academic specialist because, you know, you can't work on NLP and a half a dozen other things because you won't become a specialist in NLP. So it means we need to think about, you know, when we're studying this space, we need to work in teams, or we need people working on a specific project and somebody else comes in as the specialist in the human-centeredness, which is how that project worked out. I was the specialist on the human-centeredness and somebody else was the specialist on the natural language processing. It did mean that I had to step back and think very hard about how we did it in a human-centric way, but we managed it, we did it. I hope to be writing that one up fairly soon. Using the right upfront tools, and that, I said, needs a team of researchers. from soft OR and problem structuring, from behavioral operational research, and the people who can do the hard methods. But they need to be multiple methods and flexible methods. And that's what we're trying to understand. What is it that's needed? So there's a lot of learning has to go on by the facilitator and by the modelers, as well as the people who are involved in it. We need to learn how to be a bridge for interpretation. And when people are doing this in the real world, when people are actually doing this in practice, they need to understand what it takes to be that bridge and how to be a bridge. And that's a difficult thing to learn how to do. And it's not something that we currently teach on most of our analytics programs. We teach people lots of analytical skills. We might teach them something about behavior, but that's about where it ends. We don't teach them how to bridge it. We don't teach them how to be a bridge. And so I've had a lot of traction recently with doing human-centric analytics design workshops to teach people who are trained analysts who are already in work how to do this bridging process, how to be a bridge and how to do human-centric analytics. And the workshops are always absolutely fantastic. People learn a lot. So is there a je ne sais quoi? Not really, as I admitted up front, because it's actually all context dependent. And of course, that makes it quite difficult for us in the realm of academia, because in order to get rigor, we often need to test and we need generalizability. And if we've got something that basically is saying, well, it's context dependent, then we're really locking down what that generalizability might be. So we have to take a different viewpoint on the way that we do it. And I'm very much looking to things like practice-based research and practice theory. And that's kind of the area I'm going for, and design and OR and how they fit together. So I think that's my last slide. Yes, it is. Thank you very much for listening. I hope now that that's going to prompt a lot of discussion.
Thank you, Christy. Yeah, there we go. Thanks, Christina. That was very interesting and very insightful. So yeah, we can open it up to the floor for any questions that people might have. You can type something in the chat if you like. You can click the react button and there's an option to raise your hand, or you can put your microphone on if you'd like. But yeah, let's just see if anyone's got any questions in the room. I've certainly got one I'd like to ask, so we'll see. Anyone? It's a question before I perhaps. Oh, there we go. There's one in the chat there from Naomi. So what would you recommend people in industry do to help bridge that gap?
So you could ask me nicely. I'll come and give you a human-centric analytics workshop. So I actually got asked to do one at OR 65, I think it was, and then from there ended up doing one at HMRC, then did one at OR 66, and did one at the Analytics Network, and then got asked if I would do one for the Government Operational Research Service. And it's basically using examples of where you've got very complex situation and you've got various bits of data, and how do you bring those things together to talk to people, and then coaching the session to actually help people to understand how they could use data to give people insights. And it's looking at data in a different way. I think we tend to fall into this way of doing things that it's like, well, we produce the data, we give it to you, you're supposed to learn from it, but it doesn't really work all the time. Sometimes people really need to have the data themselves and to be able to play with it. At which point we need to think about their situation. We also need to listen to what they're saying. So something I found very powerful was literally just to listen to the pain that people were telling me. Write it down, make sure that you're triangulating the information. So you're not just getting data, you're also writing down what people are saying. You're doing kind of qualitative analysis. And then go away, find data that's about that. If you've got some knowledge about algorithms and how algorithms work and stuff, you will be able to think like, well, actually, what they're talking about there is a segmentation issue. So maybe if I use a bit of clustering, maybe a couple of different algorithms, then I can kind of talk to them about what's going on with that and what that's trying to showing. I used a histogram at one point that I'd also used clustering on to show different parameters for demand that were imposed on top of groups that people had developed. That you take that back in the room, and if people go, oh, I don't really get that, you try and change it and take something else back in the room. Sometimes even the simplest of visualization, just a bar chart showing things will be enough to actually trigger people. And then it's a matter of the opportunity to have iterations. So you need to be able to iterate and do it more than once. And also, if you can, see how they use it. So an opportunity to touch base again. So I would say always set up a few workshops with people or a few points to be able to be in contact with them. Listen to what they say. The first lot of data is based on what they're saying and what they're thinking. And the next one is how you're bringing it back in the room and you're listening to them again. You're both having the opportunity to reflect on that and what's happened with that. And then you kind of get to your next iteration. And then it becomes more like an agile design process. You start simple and then you build up the complexity as you go. But yeah, I would say, have a workshop.
Yeah, thanks, Neil. That was essentially exactly the same question I wanted to ask, because you mentioned something at the start, Christina, about people being wedded to spreadsheets.
Oh, yeah.
And it made me think when you said that, how many people I've witnessed in organizations building themselves into quite senior positions because of their proficiency or not with a spreadsheet, without really thinking about the sort of human implications of decisions they make based on that. And it kind of made me think of the whole socio-technical landscape, where it's about, thinking about the social and technical dimensions of the design, implementation, use, and even the implications and consequences of these sorts of things. So, yeah, I can see Chris has just raised his hand. Chris, would you like to put your microphone on and ask a question? Thank you.
Yeah, thanks. It's really fascinating talk and really useful and interesting insights to be had from that. I think that there is a sort of certainly in the government department where I work, there is an addiction to dashboards. I mean, it just seems to be the solution to everybody's problem. Oh, we'll build a dashboard. Long before they've worked out what the dashboard is going to say and how that. So I mean, be interested in your take. So if people come to you with that kind of solution, kind of already locked on, and you want to kind of dislodge that and get them to actually go back to first principles and understand there's a bit more to it than that. We may have other ways of approaching this kind of human computer interaction. What's your what some go-to tips really for taking that conversation and getting something more productive out of it?
Ooh, so dashboards usually can't do visualizations over time because you would actually have to have it seeing it each week, and it's still not going to show you how it changed each week. So I think using something, I mean, one of the most powerful visualizations I did in the whole time I worked in that organization, and one that actually got behavior change, was I took the data that they used to deal with every month to do their forecast, and that some of them, the demand planners were using every day to say whether products were going to, like, too many had been taken off the shelf to sit with the forecast. And they didn't, they had to pull that data every day in order to use it. So they weren't actually visualizing, they weren't using it in any other way. They were putting it on a dashboard on their supply chain summit thing that they had on their SharePoint, but that was all they were doing with it. They weren't doing anything else. So I took that data and I visualized it by visualizing it at the transactional rate, daily rate, weekly rate, monthly rate, 3 months, which was their lead time, and 3 months aggregated across their cross-sectional production. So these are the things that they produced together. And then pointed out that actually what they produced at was this final one, which was cross-sectionally and 3 monthly aggregated. And of course it was smooth. It wasn't particularly volatile. And I was like, so what you're doing is you are rescheduling based on this transactional volatility. And actually what you're dealing with is this smoothness. Well, what are you doing to yourselves? And it was, the insight was incredible. I mean, just putting that visual in front of people, and that created behavior change more than anything else I did in the whole time I was there. And I'd got clustering algorithms, forecasting algorithms, all sorts of wonderful things. We weren't in the era of AI quite at that point, but I mean, well, I say clustering algorithms as an AI, yeah, but it's none of those actually landed well enough for people to really see. It was only when I did that, and that's that transformation over time, just by doing one slide, another slide, another slide, another slide, so they could see how it transformed over time. So I think the time aspect is a really important one for moving people away from dashboards, because you cannot see how things change over time in a dashboard. I mean, you could say, well, I can look at it every day. It's like, yeah, but that's not the same as seeing how it's changing over time, is it? Yeah.
Yeah.
And anything that is subject to change, I mean, obviously that's going to be time bound, isn't it? It's going to be temporal. But anything that's subject to change, I think dashboards just don't do it at that point. And they're always limited by what the visuals can do as well. So if you can step outside of that and produce something that actually steps a bit further. I mean, another thing I did with them, this is why my paper is now going to a mathematics journal, was Venn diagrams showing where things were right first time. And that actually took some basic probability calculations on where things were right and wrong, and putting it into, I did it in Excel. To be honest with you, I did it in Excel. But it meant I could do it on one spreadsheet, have all the data fed into one spreadsheet, and then have this visual on the other spreadsheet. And it showed them exactly where things were right first time and not right first time. And then they started being able to go, oh, right, so that's holding everything up. Yeah. So I think it's very much simple, if possible, and speaking to context, which dashboards often don't do.
Yeah, that's really helpful. Thank you.
No worries.
Thanks, Chris. Any other questions from anyone?
Yeah, I've got a question, Oliver.
Tony, yeah.
Yeah. Christina, very interesting. Just wondering how digital twins might affect the sort of techniques that you're talking about, and how that might change things. And certainly when you're talking about flows and points, I mean, you've got a dynamic system in place then, haven't you?
Yeah, I mean, it's going to be really interesting to see how people interact with digital twins. I mean, in my experience with simulation, people expect simulations to look like the real world almost, because that's what they experience in games.
Yeah.
And I think you have to kind of get them through that so that they can actually relate to what they're seeing in the twinning environment. They're also, for some people, they're prohibitively expensive, because they take an awful lot of time and resource to get going in the first place. So although they may be very useful in some places, in some firms, I'm thinking particularly in production for very large companies, I think there are other places where they're never going to quite get to the point where they're going to have a digital twin, unfortunately. I mean, maybe with, you know, AI and the sort of like the revolution that's going on at the moment, but I'm not sure. I don't know. You just have to see how that journey goes.
You're right. It's capital investment. It's capital intensive, isn't it? It needs a big company.
It needs a big company. And I mean, the amount of money that Siemens were proposing to charge for it was just off the scale. I was like, what? That even their own branch went, no, we're not doing that. And of course, companies charge within the company, don't they?
Yeah.
You know,
so yes, they do.
Yeah. So it actually was much cheaper to use Simulate. Much cheaper.
Yeah. Very good.
Yeah, brilliant. Thank you. Any other questions from anyone you'd like to ask Christina? Yeah. Okay. Well, I think it's like all the questions for now. But Christina, that was a very interesting and very insightful presentation. There had lots of really valuable and useful insights into different approaches and techniques, and some actually really good recommendations, I think, for people to take away and implement practice. So yeah, very useful. So thank you everyone for coming along today. Tony, did you want to?
Yeah, I do.
Yeah,
I just want to jump in and thank everybody for coming along. I particularly want to give a vote of thanks to Christina for her talk, and it was very informative, I think. Some of those things I didn't know about, and I was very interested to listen to. So excellent. And I think we should just give a round of applause, really. I think that would be great. Physical round of applause. Yeah. Okay. And just before we pop off, because we all want to get out in the sunshine, don't we? I'm sure. I just want to tell you about the next event coming up for the Northwest Operational Research Group, and that's in June. I haven't got a date yet, but you'll be notified in the same way you were for this one. And it's another colleague, I think, of both Christina and Oliver, Professor Gary Graham, who's going to come along and talk about a very informative topic, I think, a very interesting topic, very lively. It's one that Trump knows a lot about. It's the identification, causes and resilience to structural breaks in the automotive supply chain. So I think that will be a fantastic event, and I'd like to see everyone at that, and I'll probably see you then. So that's it, Oliver. I'm going to hand back to you before signing off. But thanks again, Christina.
Yeah, thanks again, Christina. Yes, and it's Bilal who's organising the next talk. With it sounds like it's going to be a very interesting discussion, I'm sure. So please do come along. And thank you very much, everyone. That's the end of the seminar today. And thank you again, Christina. And I'll see you on Monday in the team meeting.
Yes, indeed. Thank you for inviting me.
Thank you. Bye-bye.
Cheers. Bye-bye.